Okay, so example 7. So in this example, we're going to take a look at the vector to float node, which is really cool if you want to only act on one vector, like modify it, and then add them back together and back together to the original vector. So what I'm going to do is I'm going to modify this color right here. So we have our usual things. We have a sphere, we have points, 1,000 points. I've created a color. I've created red color, so 1, 0, 0 for every point. And I now want to make them into yellow, like this, by doing 1, 1, 0. But I'm not going to do it in color node, I'm going to do it in the VOP, just to demonstrate how the vector to float is used. So let's go into the VOP and see how it's done. So in here, first, we need to establish one thing. So CD color is a vector. It has a X, Y, and Z component to it, or more or less a R, G, and B component, as it is color, red, green, and blue. But what we want to do is we want to take this vector and we want to divide it up into the 3 different components. And how we can do this is by the vector to float. What this node will do is it will take a vector, an incoming vector here in a vec input, and it will output the float value at 1, float value 2, and float value 3. So each of these values defines one of the axes or colors, so R, G, and B, or X, Y, and Z. So let's say we want to keep X the same and Z the same, but we only want to work on the Y component. So what we can do then is we can add the contrary node to this, which is float to vector. Oops, sorry. So we have one node called vector to float, which is this, which takes a vector and divides it into 3 components. And then the contrary to that, we have a float to vector node, which takes 3 floats and combines them into a vector. Okay? So we want to pipe the first float value 1 into the float value 1 to the float vector. So that means we're going to keep the X component the same. That's not going to change. And we also want to pipe the float value 3 into float value 3 of the float vector. That means that the Z or the blue component in the color is going to be the same. We then want to add 1 to the Y component or the G component in this, which means that we're going to pipe the float value 2 out to an add node. In the add node, we're going to pipe the float value 2 to the first input. We're going to pipe the sum into the float value 2 or the Y component or the G component in the float to vector. And we're going to do a constant and add 1 to the Y component here. As you can see, X stays the same, Y gets added 1, and Z stays the same. And this means that we have basically done the same as we could have done in the color node by adding a 1 to the Y. We're going to pipe this vector out to the CD, and we're going to visualize the VOP and see what happens. And it turns yellow. So essentially we could have done this in this, right? We could have just added a 1 here. Like that, simple. But that's not the point. The point is that this can be used much further than just like adding a single number to this. We can do a whole wide range of things to this. We can add animated things, we can do whatever we want, really. And this is what makes this really useful, vector float. Another thing we can also do is we can do get vector component. And this is as if we only want to work on a single component, but we are not really interested in keeping the other values. So let's say we only wanted to work on the Y component of the color. We can pipe the vector to component, we can put it to 3D vector, and we can put it to component 2. This means we will get the values of CD or Y component, but we don't really care about the 2 other values. So these are just 2 different ways to kind of work with vectors and kind of divide them up and like kind of use the individual float values in them to modify things and do other stuff, basically. Yeah, I hope this was useful. This node is very useful. I use it all the time when I do math inside of VOP. So yeah, thanks guys.